Greetings again. This is Rick Powers in Basic Statistics with Western Technical College. Lesson 8, Describing Data, Part 4, Measuring Variation. Recall from the previous lesson, finding a measure of the center is bad by itself since it does not tell us what to expect. Our culture of data-driven decisions does not usually understand this concept. It is not a good idea to base a decision on a central measurement if you don't understand the variation in it. Not only that, but you need to understand why a number changes. Are sales down because your employees are bad at selling? Or is it a change in the demographics of your area? Or is it the weather? Or is it lack of quality in your suppliers? Experience and wisdom are more important than just numbers. So then, what can we use to measure variation? One answer, the range, which is equal to the maximum minus the minimum. Example, data item 6, 11, 19, 20. The range is 20 minus 6, which is 14. Note the range is the number 14. However, this measure of variation does not actually consider all the data items, only the max and the min. So we need a way to measure variation that includes every data item. So we use the standard deviation. It is a measure of the variation of the data set from the mean. Here's the formula for the sample standard deviation. Pretty complicated, but note, I want you to be able to use this formula and show your work in finding the standard deviation. We will go through each symbol, then do an example. The X with the subscript I refers to each data item as a numbered list. If I have a list of data, 6, 11, 19, 20, X1 is 6, X2 is 11, X3 is 19, X4 is 20. The X with the line over it is X bar, which is the mean or the average. The letter N refers to the number of data items, which is called the sample size. So for 6, 11, 19, 20, then X bar is the mean or the average. 56 divided by 4 is 14, and N, the size of the sample, is 4. Some people are not familiar with capital sigma, the Greek letter. The meaning of capital sigma is the operation of sum or adding together. An example, the sum of 1, 4, and 9 would be 1 plus 4 plus 9, which is 14. So here are the 6 steps using the formula to find the standard deviation. First, find the mean. Second, subtract the mean from each data item. Third, square each result. Next, add the square numbers, the sum. Divide by n minus 1, then take the square root. You can write the numbers in columns to keep track of the steps. Recall the mean is 14. Note that the square numbers are all positive. Data values 6, 11, 19, 20. Subtract the mean, subtract 14 from each data value. -8, -3, 5, 6. Square those numbers. Square of -8 is 64, square of -3 is 9, then 25, 36. Add those numbers together. 64 plus 9 plus 25 plus 36 is 134. Then divide by 3, n minus 1. Then take the square root, is approximately 6.68. Two other formula considerations. First, if our measurements are a population and not a sample, then the formula has capital N in the denominator, not n minus 1. Second, there is another formula in the textbook which might be easier to compute, but for most situations, you should use technology, not formulas. Besides having a slightly different formula, the population standard deviation also uses a different symbol, not small s. It's important to keep track of the different symbols, especially to know the difference between the symbols for measures of the population and measures of a sample. So here's a table. That thing that looks like an O with a tail or something is a small sigma. So the population mean is the Greek letter mu. The population standard deviation is the Greek letter sigma, small sigma. The sample mean is x bar, x with the line over it, and the sample standard deviation is the letter S. There's another number related to the standard deviation, which is often used in textbook. It is the variance. It is the square of the standard deviation. The symbols used are just the squares. So the sample variance is S squared, and the population variance is small sigma squared. If you have the standard deviation and you want the variance, then square that number. If you have the variance and you want the standard deviation, take the square root of the number. This is especially important to keep track of when watching videos, since some teachers use the variance a lot. Here's an example to demonstrate the meaning of the standard deviation. Consider these two data sets, variable number 3, variable number 1. Note that the ranges are equal, below 140 to above 240. Those ranges are equal. And also the means, the averages are the same, equal at 200. But the standard deviations are not equal. For variable 3, S is equal to 30. For variable 1, S is equal to 20. The data for variable 3 is more spread out from the mean, so the standard deviation is larger. End of lesson 8.